necessary for music, which
Sorry about that.
meant maths, physics, philosophy, music itself. Uh, um, and they too were destined to become military bandsmen. William was born in 1738 and joined in teenage years. And this is Hanover, and so it was the Hanoverian regiment that he joined. Now, at that time, um, uh, the King of England, King George the First, it was at the time, was also the Elector of Hanover. Um, and so there's a shared role in terms of what of the governance of the two things. That also meant that the unit that Sir William was playing for, military bandsman for, had this connection to England. So William did that, joined it, became, was very, very effective. And in 1756, England had one of its periodic periods of crises with France. England has fought most of the other countries in Europe over the centuries, probably France most of all, and this was a period where there were tensions with France. So what King wanted to do, this is King George II by then, right, was to bring the Hanoverian unit to England to reinforce the country's defences. And so William came with it in 1756. And William was a bright lad. He looked around the place, and what he saw was a pretty wealthy country. The Industrial Revolution was just getting going. England was a very uh, successful trading company. We had these various distant colonies, including one across the Atlantic that was doing quite well and helping the wealth of the country. So William saw lots of money. He saw lots of wealth, and he knew that money and wealth meant families that wanted music, they wanted education, they wanted concerts. So he put this away as interesting information. After a year or so, the crisis was over, and William's unit goes back to Hanover. But William, as soon as he can, leaves. He actually absconds and deserts, which caused some problems for him a bit later, which were resolved. But basically, his father encouraged him to leave as soon as he could, and he comes to England in 1757, the 19-year-old lad. Now, he's not the only person who's still doing that. So he arrives in London as a German musician looking for work, and he finds that London is full of German musicians looking for work. But he had the good sense to say, well, let's try somewhere else, go further north. And he went to various parts of northern England where there were many developing towns, Halifax, Leeds, and so on, just getting going with industries, just getting going with good middle classes who wanted to have education for their children, teaching them to play, to sing, bands. Um, and he found he could find regular employment with these in these towns over northern England, Leeds, Halifax, and elsewhere. It was a fairly lonely life. Um, he was sort of accepted as a tradesman, but he would be in one town for a bit, then move on. Indeed, did quite a reading as he went from one town to the next, and also enjoyed looking at the sky when he got the old clear night. So he had this sort of rather peripatetic life, and he had just did this for some years. And he just got a rather good job in a northern town called Halifax as the chief organist, um, and was just working out, what he would do there. Well, he saw an advertisement for something different entirely, which was to be the organist at the Ottoman Chapel in Bath. Now, I talked about English towns being doing quite successful, doing quite well, and lots of demands from musicians. This was much more true of Bath than anywhere else. Bath was where the fashionable society, including royalty, would come from London to enjoy themselves. They came because it's called Bath because there are natural baths here, and people came for the waters to improve their health, but they found that drinking and parties and concerts and so on also were jolly good for their health. And it was a bit of a place to go and bring your unmarried daughters and unmarried sons and let them do what they do. So lots of partying, lots of money, and lots of demand for musicians. So William came as his organist. And as an organist, you tend to be an organizer of concerts and so on, and quite quickly established himself in Bath as Mr. Music. Didn't take many years, and so he had lots of pupils, he had lots of concerts, he had lots of things to organize, and he'd written lots of music. I mean, I should have mentioned earlier. He wrote symphonies, he wrote trios, he wrote some choral music. And was doing really pretty well for himself as a musician. Um, and after a while, well, when he was established in Bath, he realized he needed help. So he thought his poor sister Caroline was stuck back in Hanover, working as a skivvy for her mother, and went back to Hanover to do a deal whereby William paid for her mother to have a paid servant rather than just an unpaid daughter, and brought Caroline back to Bath initially as an experiment, but actually that experiment lasted 50 years. And Caroline came back, and initially as William's housekeeper, to sort of manage his affairs. Quite quickly, he realized she could sing, and so he trained her to be a singer, and she became actually really good, and began to do solos and so on, and began to also start organizing some of the cool stuff. So she became a really important part of her life. Okay, let's go on. And as an example of this, this is a concert that William did in 1778 of Handel's Messiah, then as now a very good popular piece to guarantee an audience. And this is a benefit concert for William. And as you can see from this, in 1778, um, in the Assembly Rooms in Bath, and William is conducting it, and Caroline is singing. And actually, another brother, Alexander, is also playing. So it's a bit of a family business. Okay. Um, but William's interests were getting broader. Um, and even from the early 70s, he's getting an interest in astronomy. It came from his father in a sense. I mean, the father, when he educated them, included astronomy as part of a normal education, as you would in those days. William had spent his wanderings in between cities, enjoying the night sky, and occasionally even here, the night sky is clear rather than cloudy. Um, but also, I think one of the reasons he got into it was that he read a book by Robert Smith about harmonics, which was helpful to him in understanding the way his instruments worked. And he played the flute, and he played the cello, and the violin. Um, and you need to understand a bit of physics to understand how they work and how tuning works and so on. And he did so by reading this book by Robert Smith, and the same person wrote a book about optics. Now, there are obviously parallels here, in the sense we're talking about waveforms and how you manipulate them, what they tell you. So he got into that. That's one of the theories about his route into astronomy. Whatever it was, he got into it and soon got quite fascinated and wanted to see what he could see for himself. And in those days, getting a telescope was not straightforward. Um, uh, They were very expensive. Most telescopes were refracting telescopes. So you had to have somebody making the brass work and somebody doing the optics. And this, particularly if it's an achromatic, optics only invented, during that century, were very expensive. So William couldn't find anything good enough, to sort of even worth thinking about. So he then turned to maybe another route, which is having a reflecting telescope. Isaac Newton had invented the basic reflector, and the one he invented was tiny. So William went down that route instead, and he realized that uh, size was important. So he began to experiment with different sorts of reflector. And of course, what he was working with here is reflecting telescopes using mirrors made of specular metal. We're all now used to modern telescopes with glass mirrors, with a coating of aluminized aluminum or other kind of metals. But that was only feasible from about the mid 19th century. Telescope mirrors before that could only be made by this highly reflective metal. It's a mixture of tin and copper. The exact recipe varied a bit, and William was quite cagey about this, but you could get quite a decent reflective surface out of it. So that was a method. And of course, big advantage from his point of view in making a reflecting telescope rather than a refracting telescope is that he only had one optical surface to worry about. And that made life easier. Um, so he did begin to make reflectors and quite successfully. And he was an enterprising chap and he experimented a bit and um, and used them to begin a program of study of the night sky. So he began to make notes of what he's doing from 1774, was making his own mirrors, had some help from Caroline on that, and made a variety of different sizes by about the mid 70s. Now he tended to label his telescopes by the length of the tube rather than the diameter of the mirror which we use now. So the example I this here is a 5.5 foot, a 7 foot, 10 foot, and his first 20-foot reflector. I'll share a bit more detail about them shortly. So he's making several telescopes and trying them out and using them. And he had some help. So Caroline could do some sort of basic stuff in terms of mixing the horse dung to make a cast of the mirror. Wonderful job. But Alexander, his brother, who had also come to England, was quite a natural engineer. He was a cellist by profession, but he's actually very good at turning his mind to a lathe and turning out little eyepieces and so on. So he, from this point onwards, was quite an important engineering support for William. And mostly he was observing for himself, but occasionally he would go onto the sidewalk in front of his house because it's a better position. And the story has it that in 1779 he was doing that, observing the moon, when a gentleman came down the road, doffed his hat and said, "No," inquired what he was doing, and William explained, and this chap asked if he could have a look through the telescope. And this chap was William William Watson. Now, William Watson was a key member of the Bath Philosophical Society, but also the Royal Society in London. So from that moment onwards, William had a route into the official scientific world. Um, you might say professional, but actually, the Royal Society in those days was a pretty amateurish lot run by aristocrats. So the idea of professional scientists didn't really exist till the 19th century, but it was the institution of science. And William, from that moment on, had an intro to them. And he began to write papers, for them, and on a variety of topics. Not very well at first, but he learned by doing. Okay, and then came his big break. So William was observing stars in Gemini as part of a double star survey. And perhaps I should start off by saying why he was doing this. It's a curious reason. um, the main question, well, people had many questions in those days about the sky and what was out there, but one of them was how far away were the stars? Now, because the Copernican system had basically been accepted that the planets went around the sun, and because we also knew at that time that despite the fact that the Earth was going around the sun, if you looked at around the sky at different times in the Earth's orbit, the stars weren't moving. So the stars were clearly very distant compared to the Earth's orbit. And Newton had pointed out, I think, first that the stars were pretty obviously other suns like our sun. So you can do a rough calculation in terms of brightness. If you compare the sun brightness of our sun compared to stars, it's about a million factor of difference, which means that they're about a million times further away by the usual inverse square law. So that they were a long way away. So people knew roughly how far away, but they didn't know, they had no means of measuring. So one of the methods, I think it's first used by Galileo, was to say, well, the parallax method is a very good way of doing it if you can measure angles very finely. But they realized to find, the angles will be very fine indeed, quite difficult to do. So one way of having a shortcut to this is if you can find two stars that are apparently in the same line of sight, but one is close and one is far. And people had also observed that in various parts of the sky, you have two stars quite close together, where one is faint and one is bright. So William hypothesized that stars in the sky were singletons, not in twos and threes, and that all stars had the same brightness. So if he found two stars like that, then where one was apparently one very bright and one was very, very faint, and then he watched them over the course of the year, then the closer one, the brighter one, would move a bit compared to the ones further away through parallax. If you could do the measuring finally enough. So he began to study these apparent double stars as a means of doing it. Now, we now know that William was wrong on both assumptions. Stars typically are in twos and threes, not in ones, and stars vary enormously in brightness. But by starting off down this road, what William began was one of his important surveys of these new things called double stars. So over the course of his career, he was the first person really to assemble important information about double stars, about their orbits, as a way of discovering things in the sky. And the other consequence of this is that as part of this survey, he's looking around Germany on the 13th of March, 1781, and he saw this fuzzy blob in the sky. And he didn't recognize it in terms of its position. So he made a note about it and checked it the next day. And no, the next few days. And he realized it had moved. So what was it? Well, the obvious thing was a comet. Comets came and went. People, were regularly finding them. So he assumed he'd found one more, which is fine. It's good news. No, it's an interesting thing to do. And so he wrote up what he had seen, and he described the positions he'd seen it in, and sent up a paper to the Royal Society. Now, over the next weeks and months, it became clear that this fuzzy blob did not behave like a comet. Its orbit was clearly elliptical and not parabolic, and is clearly a long, long way away. And it was about a year before they actually confirmed it. But basically, it was clearly another planet, a new planet. Now, this was a big deal because the known planets were Mercury, Venus, Earth, Mars, Jupiter, Saturn, had been so since antiquity because they're all naked eye objects. Mercury, not so much from our part of the world, but easy enough if you're near the equator. And suddenly there's a new one. No one had thought of this. No. And what's more, it's twice as far away as Saturn. So the solar system had doubled in size, and suddenly people thought, well, what else is out there? It was a huge opening up of possibility. And William went from being a very obscure musician who did double astronomy to being, famous around Europe. The news was viral, and his fame spread. And one of the people who were interested in this was the King George III by then, who had genuine interest in science and knowledge, but also realized that this was sort of a possible source of soft power for him and his court. So he, with some encouragement from his courtiers, invited William to come up to nearer his court in Windsor to be the king's astronomer. Now, there already was the Astronomer Royal who did the boring stuff down in Greenwich, trying to get positions of stars more accurately, which had an important scientific purpose to enable navigation, which is what most astronomers try to do. But this is different. This is about showing interesting things to impress people and to spread the wonder of the heavens. So William accepted this post coming up to eventually Slough. Um, got a pension of £200 per annum, which actually wasn't a huge amount of money because he's doing quite well, but it's good enough to live on. And that made him move to Slough in 1786 and a new life. And suddenly they were mixing with the king's court. The king would bring visitors or send them over. I think sometimes the king got slightly bored with people staying and said, "Go and see the no Mr. Herschel's telescopes." And a new social life for William and Caroline. Caroline, of course, went with him. She had been offered jobs elsewhere as a singer, but she really appreciated what William had done to rescue her from Hanover, and she said, "No, I stay with my Buddha." So she went up to Slough with him to their new life. Okay, so that changed his life. So he became an astronomer and a telescope entrepreneur. He was producing the best optical telescopes in the world by then, and indeed, when they checked out his telescope with the ones at Greenwich, to sort of trying to understand how the discovery had been made. They said that these clearly are far better, but of course they're doing different things. Telescopes at Greenwich were doing this very fine positional work. They didn't care much about what they were seeing. William was always more interested in what they were seeing, and that's why he went for this approach, more aperture, for example. And he was producing the best telescopes in the world of that type. Huge range, from 5 foot to 40 foot. He's making these mirrors, and of course the big ones. There's a lot of metal. If you picture a sort of a 19-inch mirror, maybe 2 or 3 inches thick, solid metal, weighs a lot, and quite a business to do it. So he became very adept at making these mirrors and churning them out, and directing staff. Alexander would help a lot, but he had workmen doing woodwork and so on. And he has a price list of what you had to pay if you want to buy these things. And £100 for a 7 foot might not sound too much, but that's in then money, multiplied by at least 100. So £10,000 for the basic telescope, £20,000 for the 10 foot, and so on. So he made a lot of money doing this. He wrote papers about them. And the king encouraged him to make them, and indeed commissioned some for various of the other royal courts around Europe. Sadly, most of them were never really used. I've been making some discoveries recently about attempts to use them in Sweden and in Ireland, but they tended to be like royal yachts or flashy sports cars. They were bought for prestige reasons rather than for serious science. So it's a rather shame because they were fine telescopes, but not many were used. But they got lots of money for William, so you didn't complain too much. So a bit about the actual telescopes themselves now. His standard telescope was a 7 foot. So this is 7 foot length, and roughly a 6-inch mirror. You can see that's quite a long focal length, an f14 thing. It's quite a short, therefore, field of view. And it's got this sort of rather sort of basic ATMoB mount, which was quite good for his day, but we would struggle with it now. If you imagine having a sort of a long focal length Dobsonian, and I've got a Dobsonian that I use for observing, it's the same kind of idea. Altazimuth, up and down movement and rotational movement, and a finder to one side. This particular telescope is the one owned by the Herschel family. So I'm pleased to say we are still very much in touch with the Herschel family, and William's great grandson is a member of our committee. So this is a telescope they have, and obviously it's a very precious thing. And there are many other 7-foot telescopes around the world. People often ask, where is the one that was used to discover Uranus? The answer is nobody knows, because for William, these were just functional bits of kit, and you had tubes, and you had mirrors, and you would adapt them, and so on. I think the various people, I think the Ardler Planetarium, for example, like to claim their telescope was the one used for discovering Uranus, but I think they're pushing their luck. It's the right type, but not the same telescope. But there you go. Well, people will like to promote their exhibits. So one thing that happened here in Bath was that the family had this telescope, and the Herschel Museum here was established for the anniversary of the discovery. And one of our very enterprising members at the time, who helped try and rescue the house, decided to make a replica of that telescope. And a guy called Michael Tabb sadly died recently. An excellent engineer, and he looked. He basically made very careful measurements of every aspect of the family 7-foot telescope, and worked out how he could reproduce it for replica, and did so. Now, he began his intention and set to it, and the whole business about rescuing the house in Bath, which became the Herschel Museum, became a big PR campaign, and there's great effort to get it done and opened. And by 1981, 200 years after the discovery. So poor old Michael Tabb, having said he'd try and do this, suddenly found himself promising to get it finished in time for the opening, which he managed to do. But he had no mirror by then. But that was the sort of secret. Didn't tell BBC either. That's just an example of some of the drawings he used. And this is the telescope he made. So as you can see, it's essentially very similar to the one that the family had. And this is the telescope now, the replica telescope, in the Herschel Museum in Bath. And we use it for observing nights when we can. It's very hard to use. And because it's quite precious, we can only use it by sticking it through a window, basically. And there's only a bit of sort of sky you can see from there. So as an observing experience, it doesn't compare to any modern telescope. But looking through it and thinking this is Herschel's view of this object is quite something. So it's got that going for it. Right. So when William was established in Slough, he made bigger and bigger telescopes, and his best by far was this 20 foot. As you can see, it's the same basic design as the 7-foot, on a larger scale. And his method of using it was to actually not sort of swing around from point to point in that sky, but to actually point it at the object he wanted the area of the sky he wanted to look at, and use the Earth's rotation to bring things into his field of view, and moving it up and down a bit in the antizimuth direction to see different parts of the sky. So that he realized was the most effective way of surveying the night sky. This telescope had a 19-inch mirror, and the several mirrors he would move in and out. And it's the one he used to do great surveys that I shall be talking about shortly. Now, people like big telescopes. This one, this telescope, 24, lasted a long time. So eventually, William handed over his telescope business to astronomy to John Herschel, and this is a drawing of that same telescope in South Africa in the 1830s. And that telescope is still around. And here's a picture of it in the Smithsonian Museum in Washington, D.C., where it exists on loan from the Greenwich Museum. I think it's off display right now. So basically, this one telescope has survived over this period. Now, I say it survived, telescope survived. I think the basic tube has, or at least most components of the tube. Because if you think about what a telescope is, what's a tube with optics in, and so on, is the essence of the telescope the optics or the tube? I think probably the tube, but there you go. So people who like telescopes like bigger telescopes, and William, was as guilty as anybody for that. So, having sort of funded himself the 24 telescope, he wanted to have a bigger one, seeing further and faster and so on. He persuaded King George to spend £2,000 to help him create this one, a 40-foot. Now, this thing, as you can see, is pretty big. There's a shed at the bottom. Same basic design. This mirror is 49 inches across, weighed over a ton. And it took years and years to make, and the money ran out. And basically, it ended up by costing twice as much as William estimated. And he fell out with the king about it. And this is really the first case of government project going over a budget. For all the usual reasons. So these things don't change. And the sad thing is, it actually wasn't very effective. It was this basic method of mounting the optics was very cumbersome and very heavy. All these wooden struts and ropes and things just didn't work the scale. The mirror was very hard to make because it had to be quite thick to avoid bending on its own weight. It's made very heavy and very difficult to actually polish and keep polished. And he discovered, I think, 2 moons of Saturn with it, and nothing else. So William was not very good at admitting he made a mistake, but basically he had. He tried to go too far. And the second image you have to the right is a picture of that telescope framework as his son John took as one of the earliest photographs ever made before he dismantled it in 1840. So it's probably his most famous telescope, but we English like a failure. So, it's also a failed telescope. Okay. His best telescope, by his own account, was this one, 25 foot. The King of Spain commissioned the telescope from him for £3,000 in that money. And the same basic design. And this is a picture of it as was provided to Spain to help, because what William did was to make the telescope and assemble it and use it in UK for a bit, and then shipped it down to Spain. And it's quite a nice picture, this. And one thing you see here, which may you find puzzling, the way William used his bigger Newtonians wasn't the standard Newtonian arrangement of the primary mirror at the base and the secondary at the top, and then the eyepiece to one side, for a very simple reason. Specular mirrors were not that reflective. They reflected about 2/3 of the light on them, as opposed to the 90% we get these days. So if you've got a diagonal as well, that's 2 reflections, and you're now losing another, a third of the light. So what William preferred to do was to actually have a slightly tilted mirror in the base and the eyepiece arrangement to one side of the bottom of the very top of the tube, and he would sit there looking down the tube, and that was his preferred arrangement for all his large telescopes. So that's known as the Herschelian arrangement for that reason. So he made the telescope. He got the money from the King of Spain, shipped it down to Spain, and this was in the early 19th century by then. And then along comes Napoleon, and his troops destroy the telescope. So it didn't have a very long life. The good news is that William did send down with the telescope very detailed drawings, and the Spanish observatory, the Royal Observatory in Madrid, kept those, and some years ago used them to build a replica telescope based on his drawings. And here's a picture of it. As you can see, it's in a building, so it's not used for observing, but you got all the woodwork and the tube and so on there. So I haven't seen it myself, as I plan to, but I'm certainly in touch with the director of the observatory, who's been very helpful to me in a variety of ways. So that's the biggest replica telescope I'm aware of anywhere. And finally, this is a telescope which I have an interest in. near the end of his life, William was getting not very good at going up steps and manipulating these large telescopes. So he made, with Alexander's help, this thing, 10-foot cross telescope, and it's 10 foot in length, but the mirror is a 2 foot. So it's a 24-inch mirror in there. So as you'll realize, this means it's a much shorter focal length. It's an f5, basically. Quite a very fast telescope, which means the mirror must have been an interesting job for figuring, because by figuring an f5 mirror is quite different from figuring an f10 mirror. I have no idea how good the images were, but of course William was mainly looking at deep sky objects, so fuzzy blobs and so on. So for that, the mirror accuracy may have been less important, but someday I hope somebody will do some studies of how effective this telescope was. But and if you want to know more about telescopes, this is a very good book, pamphlet by Andreas Maurer, put together some time ago, which basically lists them all, where they are and what's known about them. So that's quite a useful resource. And inside, you've got one diagram you have is basically all the various telescopes. And as you can see, they're all basically the same design. Standard Newtonian type tube, obviously with a Herschelian eyepiece arrangement of the big ones, and an azimuth mount, just varying in size. So that's William himself in 1785, looking handsome and thoughtful. I talked about his studies. The one thing he wanted to do when he got to Slough was to actually understand the deep sky. Lots of people were much interested in comets in the 18th century, but people had also realized there were these fuzzy blobs there that didn't move. And Charles Messier had done his list of these fuzzy blobs that don't move. And the main motivation was really to say, don't worry about these things, they're not comets. And William seems to be the first person to say, well, what are they? And he began a comprehensive study of the northern night sky, bit by bit, to look at these things. And he realized the bigger the telescope he had, the better. So he did this very systematically over a period of about 20 years. He carried looking double stars and did a comprehensive list of those. But with deep sky stuff, he got up to count over 2,500 objects. And that was quite something. No, it really was. Messier did 100, Herschel did 2,500. And this 2,500 is what in due course became the NGC we all use today. And he also updated various star catalogues as well. So he was a very systematic guy. And this is a chart done by our colleague Wolfgang Steinecker. If you want to understand William's observations, what he saw, Wolfgang Steinecker has a most amazing book you can buy on Amazon, which gives every possible detail you can want. Quite a doorstopper. So this shows the grey triangles are grey areas show the sweeping areas, and the red dots are discoveries he made. As you can see, for lots of galaxies around Coma and Virgo and Ursa Major, many galaxies by him. So quite something. He also used his work to try and do things like say, how big is the galaxy? What shape is it? And again, he had a method of doing that. He imagined his telescope was big enough to see the edge of the galaxy. So if he just pointed a certain direction and worked out how many stars he could see, then that gave him some sense of how many, of how far, of how many stars were in that direction, and therefore what shape the galaxy was. Now, not a bad idea. Of course, his telescope couldn't see to the end of the galaxy, but again, it's a method and a process. He also began to speculate about these nebulae. What were they? Now, you can see sort of fuzzy blobs. Were they unresolved star clusters, or were they something inherently fuzzy, a gas or something? And that was debated, for long after his time. But he was the person who, tried to see for himself, record what he saw, and hypothesize what it's all about. And he was the first person to do that, to treat the universe as something to be absorbed, like the natural world. So, and this was his thought really that if you look about, looking at nature, look at creatures, nature, trees, and so on, you can see young ones and old ones and so on. And he realized that nothing changed very fast in the night sky. So if there were, young clouds and old clouds, you couldn't expect to see them aging. You might see a young one there, an old one there. So he tried to envisage the things he was seeing in that kind of context. Um, and he did other things. He made an estimate of the sun's direction of movement in the galaxy, which turned out to be right. He was actually a bit lucky. I mean, he actually only chose a few reference stars, and they happened to be in the right direction. He hypothesized the gravity as an important agent of change. Now, again, what was changing things out there? Um, so that's really really quite something. He's also the first person to assemble data on this kind of scale, because he realized he had to amass a lot of data about these first things to understand them. So large scale data acquisition, recording, and so on, processing, publishing. And he realized that this is best done not by one person. So I'll talk about Caroline in a bit, but what he quickly realized when he got to Slough was the best way of doing observing was for him to be at the telescope, and he says to Caroline to be inside making notes as he called them down. So the William was the actual detector, if you like, and Caroline was the recorder. Now, the business about separating out detection and recording information is a huge issue now for science in any big place. And William's the first person to do this systematically with his sister. So he made various solar system discoveries. More moons, Uranus, more moons, more of Saturn, and so on. I wrote papers about them. And he also discovered infrared. He studied the sun as part of what he was doing. He realized there's plenty of heat in the light coming from the sun, and wondered which of the colors produce the heat. So he had a simple experiment to split the light from the sun in a spectrum, and put thermometers on each of the colors, and found to his surprise that actually the thermometer was most affected was beyond red. He didn't do much more than that, but that was the discovery of infrared. It's a sort of detail in his life, despite being quite a big issue. So what did he achieve? He said himself, I've looked further in space than ever a human being did before me. And that's true. The most distant galaxies were 400 million light years away. And no one was looking that far out until a century later. Patrick Moore called him perhaps the greatest of all observers. Michael Hoskin, a great history of astronomy expert in Cambridge, who died sadly recently, said some astronomers are great builders of instruments, some are great theoreticians, and some are great observers. And William Herschel, in his view, excelled in all three. He certainly had a systematic approach to studying everything in the night sky, and he laid the foundations of deep sky modern astronomy. So how do you do it? Education, intelligence, hard work, persistence, social skills, health knowledge, and luck. People said to him, "Listen, William, your discovery of Uranus was pure chance. You happened to see it at the right time, and record it." He said, "No. I was surveying the entire sky, and I would have found it at some point. No, anyway." But no, Uranus takes 84 years to go around the sun and happened to be in Gemini, very convenient place. So he was lucky. But astronomers, like generals, need good luck, but he's very good at using his luck. Later in life, at 50, he married a wealthy widow, his landlady. That's how big a change had quite an impact. William slowed down from them. So you go on holidays together. It also meant Caroline suddenly went from being a partner to being no, not the lady of the house, which caused some difficulty. Um, but that got better because then when John Herschel came along, suddenly Caroline had a nephew to dote on, and William went travelling. He toured the country. His name meant the doors were open. He even went to France during the brief period of peace in 1802 and met Napoleon, and they had an interesting talk about horses. Handed over to his son John from 1816 and died 1822. Okay, Caroline. Caroline William's sister. I talked a bit about her in Hanover. William brings her to Bath and why, and did these various things that she did for him. Caroline became an increasingly important part in what William was producing. And she was, not merely being a very good record keeper, but she began to be writing herself and communicating things and became well known. So Miss Herschel was a very respected person. And in 1787, the king was persuaded that she should be paid a pension as William's assistant. So she became the first paid female astronomer anywhere. I mentioned the marriage um, and its effect, but Caroline herself discovered 8 comets. She mainly did comet stuff when William was traveling with his wife, and she went back to Hanover on William's death, somewhat too hastily, I think, but did carry on doing her cataloguing work, particularly to help John Herschel, her nephew, to do his further studies. What Caroline typically did was this: William's catalogues of his observations tended to be on this night I saw this, and the next night on this night I saw this, which is fine as a list, but not very sort of approachable for somebody trying to understand the whole. And Caroline turned that into a catalogue, what she called a zone catalogue, based on position in the sky. So she became the scientific partner through the 24 telescope, doing the data processing and so on. And a revision of Flamsteed catalogue and the zone catalogue are referred to. And this is a picture of the zone catalogue. Quite good writing. Again, this is by Wolfgang Steinecker. But imagine doing all the stuff by hand. That's what she did. And she had to update the epoch of the positions of these things. So every object, she was working out what adjustment was needed for the epoch change. And she just put it all together. Very patient, very systematic. Never made mistakes. This is a picture of Caroline in 1847. She looks a bit grumpy, but she's 98. Alexander the brother, I mentioned him briefly, born between Caroline and William. No picture of him. He wasn't a very happy character. He got bullied by his brother-in-law as a musician. Came to Bath, um, and stayed in Bath for most of the rest of his life. And he was very helpful as a musician, also as a sort of mechanic making things. But he was a sort of vulnerable person, and William and Caroline looked after him. But he was actually very helpful. I think he probably should be seen to be probably bipolar in today's terms. So he wasn't very good with women and wasn't with money either. But there you go. Okay, John. John is the wunderkind son of William and his wife. Born very late. Born into a very well, by then quite wealthy, but also very social household. Um, so in the 1790s, the good and the great were coming to visit William and Caroline, seeing things, and little John would be there, running around, listening to conversations and joining in, and clearly a very bright lad. William was very keen that he should have a good education, and particularly mathematics. So, because William was self-taught, and he realized his mathematical aptitude and skills weren't really as good as they might be. So he went to Cambridge and passed out top as a head mathematician, as a chief wrangler. Um, and he made one attempt to escape from the family life made for him by being a lawyer, and found he found it rather dull. So accepted going back to astronomy after seeing his family, seeing William on a family holiday. Traveled around Europe and in the 1820s. And by then, his name and William's name would open doors everywhere. So he traveled with Babbage, the computer guy, and he met Laplace and Fraunhofer and Humboldt and the good and the great of Europe. He was a fairly manic character. Was doing lots of things, too many probably. Lots of projects he started, not all he finished. Um, and happily, he had good friends who realized that he probably needed a good wife to settle down with. So he was introduced to Margaret Brodie Stewart, who came from an evangelical Scottish family with Indian connections. Um, who was not sure if John's religion was worthy of the marriage, but took some persuading. But they did get married at 1829 and had 12 children, all into adulthood, which is quite something in those days. He was very much involved in the politics of science. Not really liked it that much, and stood to be president of the Royal Society. As a reform movement, he wanted to reform how it all worked. It was a very aristocratic body, but wasn't elected. So instead, he went down to South Africa, took his entire family with him, and had 4 lovely years on the Cape, basically mapping the southern sky in the way his father, William, had mapped the northern sky. Um, and they had an idyllic family life. They lived in a house with plenty of servants, and enjoyed the life out there. And did plenty of traveling and studied botany, and made babies, basically. I had a fine time. He comes back to England in 1838, a very celebrated man by then because of what he had done in surveying the southern sky. Queen Victoria had just become queen, so and there was a sort of celebratory mood. Made a baronet, and he had gone back to Slough. Then he found that the railway had come to Slough, so all kinds of visitors, would appear in more numbers than he wanted. So he moved to Kent instead. Um, he had various offers of jobs being an MP and so on, and other things, but he's happiest back at home with his family. And he died in 1871. His achievements. He set up what became the Royal Astronomical Society in 1820. He went over double stars catalogue by William and published a much larger catalogue of them and got the RAS gold medal for that. I talked about what he did on the Cape. He published the results of that in 1847, and that's what did lead to Dreyer and the NGC. So basically, if you do any deep sky stuff, you're using the material that the Herschel started off with. But he wasn't just astronomy. He wrote. He was very active in mathematics first after his time in Cambridge. Founded an analytical society with Peacock and Babbage to try and improve teaching of maths. Um, English mathematics was stuck in the habits and notations that Newton had used, and the Europeans had moved on, and he was trying to encourage Cambridge to go with that. They didn't at the time; they did later. Published many papers on mathematics and got Royal Society awards for that. And he also published in 1830 a discourse on natural philosophy. It's the first book in English on the philosophy of science, and it's quite a good read. It talks about basically, why you do science, how you do science, and what science could then tell you. And the rationale as to how you do it and why you do it are things one can recognize today. They're written in the language of his day. What's equally fascinating is his summary of what had been discovered, because of course the 1830 view of that is sometimes like ours and sometimes very different. So I do recommend that as a read if you're interested by this thing. And lots of other contributions on geology, meteorology, and goodness knows what else. He's also a major person in development of photography. Um, he was identified some of the key chemical processes that enable photography to work, met Fox Talbot and helped him to do a variety of things, including how to do fixing, and and invented many terms. He popularized the term photography, but he invented the terms positive and negative and so on. That's a picture of him just on his marriage year. That's his family, 12 children, all living to adulthood. And it's a picture of him in 1867 after one bad choice he made. He was persuaded to run the Royal Mint by the government of the day. Um, it's hard to imagine somebody less suitable for this kind of task. He was a shy, quiet, retiring person running a mint at big industrial enterprise, and he hated it. We think he had a nervous breakdown, and certainly this is the way he looked after it. And in fact, quite a famous picture by Julia Margaret Cameron. But he's happiest back at home with his family. So lots of achievements and widely respected. Somewhat forgotten figure today, and we're trying to rectify that. But in his day, he was Mr. Science. He corresponded with anybody, everybody, and was well known for that. But because he had no single big discovery, as his father did, his name is somewhat faded from public view. Our society, we were founded in the 1970s to rescue the Herschel Museum in Bath. I talked about a house in Slough. There was an amazing brick house in Slough where all this amazing work had been done by William and later John, which would have made a fantastic science museum, science park. But unfortunately, 1960s, by the time the house was pretty well falling down, the family couldn't keep it up anymore. The spirit of the age was knocking these places down and building skyscrapers instead. So if you go to Slough now, you'll find the Herschel name everywhere, but very few buildings associated with them. Partly because of that, when the same thing looked like happening in Bath in the 1970s, people recognized that the house, where William discovered Uranus, was actually a key thing to keep. Big campaign started, helped by Patrick Moore, and that's what the society set to do and did. So that's now a very successful museum. And what we do is we do lectures on astronomy, we organize conferences. One thing I'm rather proud of, we have a prize lectureship for early career women astronomers in Caroline Herschel's name to try and help them on their way, because women are discriminated in astronomy now as there have been in the past. So no, that's something we do in Caroline's name, and we do some research and provide sources on Herschel history, and we try and get concerts of Williams music. And this is just some pictures from the museum. This is the front of the museum. This is the workshop. This is the replica telescope, and this is the back garden where William made his discovery. And that really is a place of pilgrimage. People turn up there and just go and stand in the garden. I think, no, this is a place where it all happened. I can understand that. Okay. Thank you very much. I hope that was interesting. I'm very happy to take any questions. Now, how do we do this? Will somebody read out questions to me, or
Well, Mario already has his hand up. Let me start with Mario, and we'll figure out in here.
Okay.
All right. Am I first?
Yep.
Great. That was a great lecture. I was there in Bath about 25 years ago, and I thoroughly enjoyed going through the museum.
Yeah.
Question I have is, how did he grind and polish the mirror? I mean, nowadays we use carborundum and then rouge or cerium nowadays. What did he use for the grinding and polishing? And the second question I have is, what did he figure it to? I mean, F10, a sphere is fine. When
Yeah.
he made the 24-inch 10-foot, that would be F5. And did
Yeah.
he parabolize it?
Yeah. I don't know what actually materials he used to do the grinding. It was, of course, a metal and polishing, rather than glass. So it's not the same problem technically. I'm afraid I don't know that. There is material in the Royal Astronomical Society where he talks about this, but I couldn't tell you. On the figuring, he knew he wanted to get a parabola, but he didn't have a means of working out if he'd be successful or not, apart from just you testing it visually. Um, so and this was trial and error. So quite often, I think he with the bigger ones, he would do it by hand from experience and put it in the scope and look at how good the image was and try and sort of work out if that was okay, and if not, do the regrinding. So trial and error, I think, is the answer. But as you say, a spherical surface probably is okay for F10, but for the F5 one particularly, that'd be quite difficult.
Yeah. Did the 10-foot mirror actually work if it was spherical?
No, the 10-foot, the 10-foot, we would, yeah. If you have a sort of an F14 mirror, spherical rather than a parabola, it'll work. It'll be pretty good for some deep sky stuff, but it won't give you a very sharp image for a start. So like all these things, it'll be a compromise.
Thank you.
I can comment on that a
Can
bit.
you come over?
Yeah, I
Yeah.
can comment on that a bit.
Take the mic. Just come stand over here.
Right, okay, I'll stand here and.
Talk to the
Yeah.
owl.
Talk to the owl, okay.
Talk to the owl.
Yes, indeed, hi. Yeah, I've been to the Herschel Museum a number of times, but it's gotta be at least 15 years since I've been there. So I brought for folks here to see a number of publications that the Herschel
Good,
Museum published, so they can see. Now, in terms of the mirror making, Smith's Optics, it's a book published in 1738 that goes into great detail about making mirrors, and they use terms like a bruiser and some other things that are a little different than we do, but typically it's with metal tools, and I think he probably essentially by trial and error and other ways did in fact get pretty good figures, and there are a number of surviving Herschel mirrors that have been tested, and there's a lot of literature describing their figures, and they're
pretty good. They're
Yeah.
pretty good.
good.
They are. Yeah.
Are they parabolas?
Some were kind of parabolic. I mean, I think Smith even talks about parabolizing a bit, and in terms of strokes and tools that you use that essentially change the shape from spherical. But I haven't read that stuff in many years, so I don't recall the details. But I can certainly give you some references that go into it. That because I think Smith's Optics is available online. It's a very expensive book that I don't have a copy of, regrettably, but it's a very cool book with, I think, 85 engravings with lots of details about how they constructed things back then. And Herschel,
the difference is now you can test a mirror, in a variety of ways. In those days, you really couldn't. It's just by trial and error.
that's right.
So
Yeah,
that's
because
one difference.
yeah, Foucault hadn't published his testing methods because that was 1850 or so. So
That's later. Yeah, that's right. Yeah.
that's right.
Come on over. Charles, you're okay, right? It's about 2:15 in the morning.
Oh, yeah.
All right.
I'll try to wake you up. I have only been
Yeah.
to the house twice, and I
Yeah.
seem to recall that there were stories about how in casting the speculum mirrors, there was an occasional explosion. Am I right about that?
You are right about that. If I take you back, well, if I can go back and if you go back here, do you see the floor of the workshop? The story has it that in 1782, William was trying to cast the mirror for one of his 20-foot telescopes, and they had a furnace in there and a great deal of molten speculum metal, and the mold cracked and the metal poured out onto the stone flags. And if molten metal hits stone, it gets explosive. So basically, the huge bang crash, and William and Alexander came, coughing out of the basement into the garden. I could have killed them. And if you go there and look at the floor, you can still see the cracked stone flags. And if it had killed them, then of course the story would have ended at the discovery of Uranus, and well, great things have happened thereafter.
No, John.
No,
Yeah.
John, indeed.
Right. Guys, all right, come on over.
I just wanted to say a word about John Herschel and his contribution to photography. His discovery that sodium thiosulfate would fix silver prints is still the process we use today. So from 1839 till today, it has never been superseded.
Yeah. And he did this. I mean, it's based on work he did 20 years earlier. And with all the things he gave, I mean, when he met Fox Talbot, he just said, no, here it is. He never, I mean, Fox Talbot trying to make money out of it. John Herschel was always willing to help anybody. He never, patented anything. He's always just trying to help people.
And of course, that led to astrophotography.
That's a discovery that should make him, I mean, put it mildly, a big deal.
Well, he is a big deal, actually. He's well known in at least historical scientific world. He was a top level genius. There was absolutely no doubt about it.
I think one of the problems with John is because he had his scope was so broad, it's actually quite hard to tackle. You may be aware that we did a conference in 2024 based on a Cambridge companion to John Herschel, which Steve Case, some of you may know, was one of the co-editors for. And this had 12 different chapters by 12 different people on different aspects of what John did. Now, Steve is also has made a start on doing a sort of a scientific biography of John, the whole man, and that's quite something. So we're encouraging Steve to do a couple more volumes and sort of finish the job, but it's difficult. It really is. It's a quite hard thing for us to grasp. I mean, John really was the last complete scientist in many ways.
All right. Shall we close this? Yeah. Various. Thank you, Charles.
Thank you very much, Charles.
Okay, you're very welcome.
Rich and Glenn, you're on.
Glenn's here tonight. I'm here
So
tonight.
you have the.
Can I try the newfangled thing?
New technology too.
You might need a press to wake it up, but
If
Oh, yeah. This is a nearly buttonless remote, which should help me greatly. We'll try to keep this brief because of the hour. So let's just jump right into it. Of course, last month I talked about this comet, and there was great hope that comet maps would round the sun. It's a sun grazer. We were hoping for it to reach like -10th magnitude as it rounded the sun. And I was actually watching. I have my H alpha telescope. I think if it's -10, I'll bet I can see it in my H alpha scope. So I set the scope up. I looked and I looked and I looked and I saw pretty much nothing, because what happened was the comet. So I can get this latency thing going. The comet. These are SOHO and coronagraph images. There's the comet on its way in, And this puff of stuff here is a vaporized comet that's being blown off the sun by the solar wind. And so the comet, a few hours before it reached perihelion, astronomers noted a brightening of the comet, which they suggested was the disruption of the comet due to not only thermal effects of the sun, but the gravitational forces. And so the comet is no more. That's great. I didn't put a slide up. There is a comet in the morning sky if you're inclined to get up early. It's comet 2025 R3, Comet Pan-STARRS, so not the Pan-STARRS comet. It's currently within the square of Pegasus, low in the east, right at sunrise, or just before sunrise. And I think it just broke naked eye brightness.
Joe Rothschild shared a picture with the club.
He did.
A nice shot.
I don't know what all those weird streaks were across the picture, but but yeah, he did. He posted a nice picture today. Check your email.
It's also going to disappear pretty quickly and not be visible again.
Yeah, it's we haven't had much luck with comets lately, but at least it's up. If you get up early, go east. It's a binocular object. You should be able to pick it up. There's a green glow in within the square of Pegasus. I don't know if Sky and Telescope has published finder charts. They have. Perfect.
I plotted actually.
You did? Nice. Thank you. Anyway, better luck next time with comet maps. As far as the planets go, there's a lot of stuff happening along the eastern horizon just before sunrise. You've got Saturn, Neptune, Mars, and Mercury. They're all pretty much unobservable. If you notice the angle that these guys make relative to the sun, that's kind of the ecliptic. The ecliptics in the springtime, in the morning skies, in the northern hemisphere, makes a very shallow angle to the horizon, making these planets very difficult to observe. So we'll just have to wait it out for Saturn and Mars and Neptune.
Oh my God.
What?
Rich, that's a once in a lifetime planetary alignment.
I know. Once in a lifetime. Yep. So don't miss it. Don't miss it. Venus is nicely visible in the west now after sunset. And when I was doing the slide deck, I just walked out and snapped a picture of it. It's I don't know. I wish Bruce were here because I don't know if these bands are artifacts or if they're sky glow. See, I don't know if you can see them. Is it purple and green bands? I don't know if that's air glow or if it's just a crazy artifact from the iPhone camera. But there's Venus right there, just after sunset in the west. It's bright. You should try daytime observing, just because. I was daytime observing today. I looked at Jupiter. I could see it in the finder scope. It was easy. Io Shadow made a transit just before I came to the meeting. So you should get out there and try to observe these things in the daylight sky. Pretty good. Now, Uranus is still visible. It's getting a little harder to see now because we're getting late in the season. But it's still grouped with 13 tau and 14 tau, making it a relatively easy object to spot. We've been showing it off at star parties. I usually announce that it's the most, I can't remember the words I use. The least impressive thing you're going to see all night. But there it is. It's the planet Uranus. I also use the line that I use for Neptune sometimes. You probably woke up this morning thinking your life would be complete if only you could see the planet Uranus with your own eyes. I say that to the people at star parties. They laugh, but it's true. So you should get out there and make your life complete by looking at that guy.
Rich,
Yes.
sorry, before you move on April 23rd, Venus will be entering that frame there, and you'll be able to see the Pleiades, Venus, and Uranus all in the same binocular field.
And I believe Uranus and Venus become very close together.
Very close, yeah.
You might see them in the same eyepiece field, actually.
Right.
And there was something said in the article on the website, your website, that
And whose website was that?
well, this guy can tell us. The website I look at every single morning. That it may be difficult to see Uranus so close to Venus because of the magnitude difference.
It's like a factor of 10,000.
Yeah, something like that. Pretty cool. It can be done. You should try it. Everybody should try it. Of course, Jupiter. is still in the sky. Like I said, I was looking at it this afternoon. I could actually see Ganymede at 5 o'clock this afternoon. I was using a polarizing filter. Jupiter is near quadrature, which is not, 90 degrees away from the sun. The sky's natural polarization maxes out at 90 degrees away from the sun. So if you take a single element polarizing filter and put it in your eyepiece, you can turn the eyepiece and adjust the contrast between the object and the sky. And so I was using that trick to kind of help me to check it out.
What kind of scope or mount were you using? Did you like dial in Jupiter, use setting circles, or?
This was it's a Schmidt cat, a 9 1/4 inch Celestron on a GEM mount. So that is a go-to mount, and I'm embarrassed to say, I actually pushed the button on the mount and said, "Could you please show me?" I know. Shame. Such shame. I'll keep this short, but many of us live in the Alt Azimuth world. Yes, we all have Dobsonian telescopes, right? And so we can play that game very easily, the altitude and the azimuth. You just point the cannon where the angles tell you to point it, and Jupiter's in your finoscope. And I do that all the time using the Alt Azimuth. The equatorial mount's a little different. It doesn't lend itself to Alt Azimuth work at all. And I have found that although I know how to work a German equatorial mount, it's not as easy as you think to just point it where you think Jupiter should be with altitude and azimuth. So yes, I did a polar alignment of the scope recently. So now it's actually pretty accurate. But as far as the alignment stars, broad daylight, you think you're looking at Procyon? Okay. Next star, you think you're looking at, Capella? Pretty close, okay. And I gave it one calibration star, and then when I asked it to go to Jupiter, it literally was just a couple of pushes on the hand controller, looking through the finoscope, and it's like, oh, there it is. So it was actually pretty successful. I was actually impressed. I didn't think it was going to work.
To the dark side.
I know. Next thing you know, I'll put a camera on that. No worries there. But I did want to take another moment to mention that there is another Callisto transit coming up. On the 6th of May, Callisto will transit the disk of Jupiter, and it's a very low albedo, about 20% dark, right? So you should be able to see it easily silhouetted against the planet. The only problem with the May 6th one is Jupiter sets a couple of hours after it starts. The next opportunity that'll be easier to see is the May 23rd event. I'll remind you of those with emails, but they're relatively rare. They're fun to watch, and so you should check it out. And then the lunar highlight of the month are the Jura Mountains and the Bay of Rainbows, which I know we're all hyped up because folks have been orbiting, well, not orbiting, flying by the moon and heading back to Earth now. More of that in a second. There's the Bay of Rainbows right there. It's best seen gibbous a waxing gibbous phase. This is it right here. Of course, you've all seen it before. It's a fabulous object to look at on the moon. Plenty of things in the area to look for. The Straight Range is right there. The Greusten domes are right down here. Those are volcanic domes right there. There's a really isolated little teeny volcano right there. See that little dot right there? That's Marin T. That's a really cool little teeny tiny volcano. Super steep with a caldera on the top that likes to be filled with shadow. So that's a fun one to look at too. So that'll be best viewed on Wednesday, the 25th of April. And I would encourage you to get out and look at that. Glenn, talk about this lovely double star.
Yeah, I don't know much about double stars, but I'll give it a try. No, Iota Cancri is called the spring alberia. It's a beautiful combination of golden topaz and sapphire blue. It's a wide double star. This is one, if I'm going to show people colorful double stars, I like to go to Alberia because I can find it no trouble at all. Cancer is a relatively faint constellation, so I usually have to go to the charts to find out where this star is, but it is a showpiece pair, and I certainly encourage you all to give it a shot. And while you're there, of course, you've got M44, the Beehive Cluster, which is what Galileo discovered it about 200 years before I did. But see, I was in high school with that little Gilbert 80 power telescope. And I remember back then we didn't have light pollution. I remember I could see a little fuzzy patch of light, just the way Galileo did. And I aimed that telescope and holy, it might have been what got me into astronomy because I see all these stars. And I remember the next day I researched in school, found out it had been discovered already before me, so I was out of luck there. But it's a beautiful cluster, great with the naked, well, if you can see with the naked eye anymore, if you're out in an area you can see with the naked eye, you're probably in luck now because I used to be able to see it very easily from my house in towns, and now it's a little bit more difficult. And M67, of course, is a lot richer, it's a much older cluster. And we'll continue going. Well, we're still doing T, huh?
Well, yeah, it's a very little star reminder. And again, this is allegedly going to be the year it'll happen, but which one of us will be the first to see the outburst?
I noticed we've gone from is this the month?
Rich,
I thought it was last year.
hey, Rich, you call me, we talk on the phone quite a bit. So one of these days, I don't like to, but one of these days you won't be able to talk because I passed away. Get the word out to the club to get out there and look for that star. I swear, within 24 hours, it'll go into an outburst.
I know. I mean, Glenn believes us, it'll happen. Anyway, when you do see it, maybe we come up with some fabulous prize for the first ATMoB member to post that they've seen the outburst. Just please notify us because the outburst will be short-lived.
I'm watching Kelly there. He's gonna assassinate me on the way out, so a giant telescope is gonna scoop on me. The outburst.
Probably should be a small Amazon box with a slit cut in the top.
Carefully. That could be the prize. That could be the prize. Anyway, yeah, we'll let everybody know, but if you see it first, yell out. Because the outburst is brief for a few days, and it'll head right back down again. So we do want to keep an eye on that. It comes up nice and early. You can go out every night and look at it now. Where are we next? Oh, some deep sky stuff.
Okay. Before I wanted to make a mental note here. We had a nice talk about William Herschel, and I just want to check out. Owen Gingrich was here probably 45 years ago now because it was the anniversary of the discovery of Uranus. How many of you in this room were at that particular talk? Owen Gingrich, we got a couple of people, yeah. So now you know who's old in this place. We're all there for that thing 45 years ago.
As if you could figure it out any other way.
And another thing, the double star, I forgot, the double star of the month last month was K Puppets. It's very low in the sky. I haven't seen it for a long time. Was it the Carlisle Star Party I was at?
Yep.
I was looking for Herschel 3945 is a John Herschel discovery, but that's another Albireo type star. And I like it better than Albireo itself because they're closer, the same colors, that topaz and sapphire. Anyway, I was looking in that area. I didn't have my star map with me, and I came across a double star. Both white, both equal, beautiful, but that's not the one. But I think that's K Puppets because it's going to be in the same area. Now, the thing at star parties, we like to show wow things. You look at the moon, look at Saturn, look at a globular cluster. The only double star I've really had success with is Albireo, the colors. But there were a couple of little girls there. And I said, you want to see the kitty cat eyes? And they, instead of saying, would you like to see a binary star with a period of 736? I said, you want to see the kitty cats? I remember that little girl looked in. Kitty cat, she's running, got her little sister who's probably 5 years old. Kitty cat, and they got their mother over there. It was the most successful thing I've ever had as far as a wow object at a star party. But it also begs the thing, we're going to talk about star parties in bits. They get out there and do some of those because they are a lot of fun.
They were little kids because the telescope Glenn had that night was literally, I swear to God, it's like this high off the ground.
Is that Orion? You brought an Orion scope that time, yeah. They kind of hard. Okay. NGC 2403, very photogenic. In fact, we get a lot of responses. I was saying that the reason we were getting a lot of responses to the Observer's Challenge was that the weather was really bad, it was cold. But I'm putting it on me because I used to send a friendly little reminder like Al does with the newsletter. I put a friendly little reminder. I get a lot of response this time on 2403. It's a beauty. Well, wait a minute. That's not 2403. It is. Oh, okay. All right. That's a different picture than what I was used to. The problem with that one is it's way out of nowhere. And it's camelopardalis. I have been saying for 50 years camelopardalis. I looked at it and I said, suddenly I think might have to look in the newsletter. I might even put camelopardalis in the newsletter,
You did.
did I?
Yes.
For 50 years, and I suddenly said, wait a minute, what's camelopardalis? I just learned within the past week that it's camelopardalis, not cameloparda. So I stand corrected for everything I've said about that constellation for the past 50 years.
We forgave you.
Anyway,
That'll tell you how obscure the constellation actually is.
oh, it is that empty space between
Yeah.
Perseus
Yeah,
and
the names are a void in between the constellations.
the camel leopard, the giraffe. Anyway, this is one way to find it, is to go through the Big Dipper. You have to go for an adjacent constellation to get there. It's about a ninth magnitude object. I think it's about 11 million light years away. I think it's associated with M81, M82, that whole thing. So, but I've seen it with a 3-inch telescope. It's just a thing of getting there. If you're a star hopper, you got some work to do. If you like Rich, you use a go-to telescope. Next slide.
Well, I will say, last night I was with the 25-inch dog, and I thought I'd go to that, and I looked up and I went, yeah, no. No. Too much climbing.
Okay, I think we have a lot of pictures of that.
There are a lot of pictures of it. Look at
Yeah,
this.
Doug Paul, Mario Mata. It is called, like somebody called it the M33, the little M33 or something like that to compare it, because it is a tiny little type galaxy. Again, we'll just go through. I apologize for not allowing each person to talk about the specs, but it is getting late at night.
We'll
Rich
just
has
keep
to go.
rolling.
Yep, Steve Bodine, Venu. Venu, that wasn't with the C star.
That's an H of C, not C star, it is C11 HD.
Oh,
Nice.
okay, all right.
Little different.
The upgrade. Okay, continuing. Dave Murray, Charles, I thank all of you that did send these submissions and appreciate it. Next one.
And this is the one from, they came out a little weird. This is one from Dave Wilbur, and I annotated it to put the magnitudes. So that, because these are sort of the guide stars that you want to find if you're going to look for this guy. These guys up here, 8494, 729084. Those are the magnitudes, and a couple of stars right on top of it, 10.4 and 9.9. And I hope Dave doesn't mind that I annotated his slide, but I also wanted to put it there because Glenn, with his small 3-inch telescope, had seen those same stars. There they are.
And I noticed that I got those two little stars near the nucleus, and over here they're side by side. That was not a mistake on my part. That's a binary star system that's between us and the galaxy. See, and I've discovered this one. It's got a period of about 5 years. I don't know if I actually caught the one that's up here, but anyway, it just shows you what you can see with a small aperture telescope. You know, I've seen all of the Messier objects with that little 3-inch scope, and it is a classic to me. This is the Edmund, it's a Space Conqueror, 3-inch F10.
That was 45 years ago.
Oh, I know. Glenn's really old. Glenn's really old. Yeah, that was 40. Glenn's sketch is 45 years old.
Yeah, been around the galaxy. Okay.
All right.
That's why you missed the Gingrich lecture.
That's right. That's right.
It was a spherical mirror.
April challenge. This is the one that's right now. It's M84, M86, and 7 other galaxies. It's actually the western half of that Macarian's chain. And you can see a bunch of galaxies just in a 1-degree field. And one thing I've always talked about, I know a lot of people, when they want to go to this area, they go by Vindomatrix, camelopardalis, Vindomatrix, whatever. Anyway, I'm going to try this, and I think I put in the newsletter. If you actually go roughly midway between the nebula and Vindomatrix, and then just do some cruising around, M84 and M86 are about 9th magnitude. So if you use a wide field, you should be able to pick up a couple of smudges. Then go to higher power and pick up the rest of these galaxies. The others are anywhere from 10th to about 12th magnitude. 6 of them were discovered by a guy named William Herschel. We've just heard about him. The other one was actually discovered maybe about 40 or 50 years later by another German astronomer. I forget which one of the ones it is. These are all NGC galaxies. Anyway, that's the one for this month. So again, I encourage you to go out there, take some pictures. My game, because I'm a visual observer, is and I might even do this at Clubhouse, Rich, is we work with a 20-inch, 25-inch, maybe Steve scope. I'm going to come with a 60-millimeter refractor, the old standard. Then I'm going to bring a 6-inch telescope, and then just work my way up. What I want to do is see how many of those 7 galaxies I can see with each of those apertures. So that's my game, and I'll try to report that at the next meeting. So I mentioned again, you can take a picture You can make a sketch, but you can also take notes. And some people, just descriptive notes. You don't even have to be an artist or an astro imager. Just take some notes. What did you see? Okay, what's coming up?
Yeah, that's a lot of fun. That's a lot of fun. Whoops, uh-oh. All right, next one. All right, here are the ones
Okay.
for next month.
Next month is Leo triplet,
Whoops.
M65, M66, and I have to go to my notes to see, this is an NGC galaxy, probably discovered by William Herschel. And they're all visible in the small aperture telescope. These guys are about 9th magnitude, that's about 9.5, but low, very low surface brightness. But that's what's coming up for next month. So again, for this month, get out there where we have some clear skies and just check out the M84, M86, and those 7 other galaxies, or see how many you can capture with your particular telescope. And next month, we have a very photogenic object there, a trio, the Leo triplet.
We were looking at those last night also. And Glenn's right, that hamburger galaxy up at the top there, that's a pretty faint object to see, but it's certainly there. So it's fun.
Okay.
Fun, easy to find too, real easy to find.
That might be it. Let's see.
I think so, I think that's the star party. Oh.
Okay, so again, keep looking up.
Observing schedule. Here, stick around for a second. Stick around.
Okay, all right.
So here's our observing schedule coming up this weekend, next weekend, and then in May. And I decided just to fill the empty space with a picture of a bunch of us looking through we were observing Jupiter. This is a 25-inch scope, of course. And I know we're looking at a planet because the 7-inch mask is over the primary mirror. We were testing this was back when we just first got the equatorial platform for it.
Was that a flash picture?
No, I don't think so.
I was gonna say, how long did it take to get the dark adapter?
It was just an exposure, but that 25-inch telescope with the suite of ethos eyepieces we use with it on a tracking platform is just to die for. The optics are great. It tracks beautifully, and it's not a go-to, but you know, we're pretty good at pushing it around. There are no buttons on that telescope.
So next board meeting is on April 30th. As we mentioned, we'll be discussing the bylaws and such, the other topics too will be discussed. I think we are at the close of the meeting. So the next meeting, we have something slightly different. We have the composer of the CFA is spending some time with us, half an hour of it. He composes music with the background of the stars and the galaxies and so forth. I don't know if anybody has gone to any of his concerts. And the director of the Center for Astrophysics, Lisa Cooley, also will be speaking. Cool. Okay. Cool. All right. Thank you, everyone.